Tammy is a principal SRE at Gremlin, where she works on chaos engineering, the facilitation of controlled experiments to identify systematic weaknesses. Gremlin helps engineers build resilient systems using their control plane and API. Tammy previously led SRE teams at Dropbox, responsible for databases and storage systems used by over 500 million customers. Wow. Prior to this, Tammy worked at DigitalOcean and one of Australia's largest banks in security engineering, product engineering, and infrastructure engineering. In this presentation, Tammy will share the many wonders of black holes, not in space, but in computer science. Tammy will explain how you can use black holes to learn how to make systems more reliable. So with a huge applause, please welcome on stage Tammy Buttow, and the presentation's title is An Exploration on Black Holes' Strange Failure Modes. The stage is yours, Tammy.
Everyone, thanks so much for having me, and thanks for the awesome introduction. I'm really excited to be here at CraftConf today. Thanks so much to everyone for coming along. So today I'm going to be talking about black holes, and this might be a new topic for you. If you haven't heard it before, that's totally okay. It's really a newish concept in the field of chaos engineering. So we're talking about black holes related to computer science and distributed systems. So I'm joining you here today from Florida. I live in Fort Lauderdale, so great to see everyone all over the world. Welcome. I'm really excited that you decided to spend some time with me today. And if you're guessing what my accent is, you can guess in the chat if you want to have a go. A lot of people like to do that. It's pretty fun. But if you're not sure, my accent is Australian. So I'm an Australian. I grew up there and I moved to America about 6 years ago, and I've been here since then, working in a variety of different companies in Silicon Valley and then also in New York. So let's get started. Today, I want to share with you an exploration of black holes. So really strange failure modes. And you can also find me on Twitter. Tammy Bryant Buttow is my handle, and I work at Gremlin. Alrighty. So really, when we think about black holes, I love this quote: "Everything has its wonders, even darkness and silence." So that's a really awesome quote from Helen Keller. And there's just some things that happen in computer science that are completely strange, unexpected, bizarre. I'm sure if you remember back to your years working in technology, you'll realize that, yeah, there were some really strange things that happened. It took us a while, days, months, years to figure out what was really going on. Maybe there are things right now that have totally stumped you. You're still not sure what's happening with these different strange failure modes. And when we think of a black hole, we often think of this type of a black hole, which I think, like, if you visualize this, but now imagine it in a distributed system, that's actually a really good way to think about this. So imagine it's somewhere where requests, where transactions go, and they just disappear. So that's what a black hole is in computer science. So today we're going to explore some really strange failure modes. I'll actually show you some demos, and I'll also show you how you can create black holes yourself so that you can actually make them yourself and see the impact of them, which I think is a really fun and awesome way to learn about systems. So what is a black hole? What's my definition for that? A black hole is a region of a distributed system where gravity is so strong that nothing, no requests or transactions can escape from it. All IP packets in this region are unable to escape. So if you imagine it like that, it's somewhere where maybe you've got a service, part of your system, could even be an entire region. Suddenly it's unavailable. Nothing can go in, nothing can go out. It just kind of doesn't exist for a period of time. So how can we actually create a black hole? Because the really interesting way to learn about black holes is to actually make them yourself. That's what I've loved about computer science. So if you think about that, this is like one of the basic principles of chaos engineering, is that we're actually going to inject failure or create failure to see the impact of that failure. Because it's kind of hard to observe failure if it's sporadic, if it happens only at 2 a.m. on a Tuesday. It's hard to understand like what's going on. You know, you'd have to wake up, know exactly that something was happening. And what if it only happens for a few milliseconds? Or what if it happens for a few seconds? What if it's a really quick thing that just happens all the time? So that's why we actually want to create this failure mode and observe it in real time. Even we don't even have to do it just by ourselves. We can do it with others, which is even better. So let's see, how do we create a black hole? What we do is we capture IP packets at the transport layer targeted by supplied port and host arguments. We can use existing traffic policies, traffic policing features in the Linux kernel to drop targeted IP packets. So that's how we can actually create a black hole. So definitely have to get to understand the Linux kernel, understand how packets actually move around, understand what we can do to sort of change these packets and impact them. But it's great to be able to understand the transport layer, and it will teach you a lot about distributed systems. Alrighty. I also really love this GIF. If you think of a black hole, so say we're trying to reach our shopping cart in an e-commerce store, we try and go in, we're like, no, nothing's there. Like, I'm not able to reach it. If you imagine any other system trying to call it and they just can't pull anything out, maybe they're trying to show the items in the cart, it's impossible. Maybe they're trying to add items to the cart, it's impossible because it's just not there. So that's how to visualize it. If you're a visual person, I really am. So I like to share both types of examples. So now let's think about a real world example that would have impacted many of you. What happens when your banking transactions are involved? So what happens if there's a black hole impacting your banking transactions? So something that I did for quite a few years after I graduated from college studying computer science is I went to work at the National Australia Bank. And I worked there for 6 years in a variety of different teams. So you can imagine over 6 years, the different types of outages that I saw, experienced, and worked on is a lot. And when we're thinking about banking systems, I worked on internet banking, mortgage broking, foreign exchange trading. So there's a lot of different types of failures that can happen. And think about it to yourself, what are the things that you would worry about with your bank account? Failures that might happen. So here's some of the ones that I saw happen to people. There would be missing transactions. So say, for example, they added $100 to their account and then it just didn't show up in the account. The balance wasn't adjusted. The transaction history wasn't recorded. That could be a failure mode. Another one could be duplicate transactions. So you add $100 and actually $200 gets added because there's a duplicate transaction. That one, people are actually pretty happy about that failure mode. Another one might be that you transfer some money out of your account. Maybe it doesn't reach the intended destination. Another one that I saw that would happen is that sometimes people's balance just wouldn't show up correctly in their internet banking portal. So that's another thing that can happen. So let's dig into this a bit more. What we're going to do to learn about this is actually look at an example using a demo application. So I find that this is a really good way to learn about failure and teach yourself about how you can create and use black holes. So this is the architecture of our banking application. We've got Python and Java services, and we also have Postgres databases. So let's look at the services. We've got a transaction history service, a balance reader service, a ledger writer. We've also got contact service, a user service, and then we've got our two databases, accounts and ledger. And then we've got our front end, and then there's also a load generator there. So if we think about this, it's pretty cool. Like I think using a banking example, because everyone works with a bank, everyone has a bank account. So you understand how these things work, right? Transaction history, that's going to show you your transactions, your deposits, your withdrawals. Your balance reader is going to show you how much money you have in your account at any time. Your ledger is where it writes all of the different transactions down in the ledger. And then your contacts is who you can send money to. The user service allows you to create users, to add more users who can then log into this banking application and create an account. So that's what our architecture looks like. You can also check this out actually on GitHub. So it's a totally open source example. I'm also going to paste that in the chat. And the cool thing about this is you can grab this code and you can run it on Cloud Shell totally for free using Minikube. So it runs on Kubernetes. That's great. You'll also be able to understand Kubernetes and different failure modes there. If I scroll down, I'll just share with you here. I do like to that it uses multiple languages. So then you're able to actually learn how different languages might fail in different ways. And if we scroll down here, you can see a little bit about what it looks like, our architecture diagram. And the really cool thing here is if you click this button, open in Google Cloud Shell, that it will actually clone the repo and spin up an example of this application in Cloud Shell for you. So that's really cool. So what you can actually do if we click here, let's just click that. And I'll quickly show you how that works. Alrighty. So we just say we would like to clone this repo, confirm. And that's it. So now it will start to actually provision your Cloud Shell machine, connect everything, get the repository, and it will start to walk you through this tutorial where you can actually use Minikube, which comes built into the Cloud Shell instance to be able to do this. So how awesome is that? I think that's really, really cool. And what I want to show you is once that's actually running, up and running, it looks like this. So now we've logged into our application. We're able to see our current balance. We can see the transaction history. We can deposit funds. We can send payments. And that's awesome. So this is what our bank looks like right now. You know, pretty common internet banking functionality. Alrighty. So one of the things that we want to ask ourselves is, does blackholing a critical path service like the balance reader result in graceful degradation of the customer experience? So if we make the balance reader service unavailable, which is showing our current balance of $7,022.62, will we see any strange errors? Let's have a look. So what we can do is we're going to go in and grab the balance reader deployment from Kubernetes. We can see we've got only one pod. So already that teaches us a little bit about this. This one pod is going to be unavailable and there's no other backup pod. We could have, you know, with Kubernetes 2 pods for that service, but there is only one by default. So you can see here when we do run that, this is what the balance shows up as, 3 dashes. So if we black hole balance reader, it looks like we don't have any money in our account or something's gone wrong, but we don't really have an error message or anything like that. It's just showing us that you have no money in your account. This is generally when people get really worried if they're using a banking product and something looks like this. I've experienced that many times where often the money is definitely there. We've got records of the money. Everything is totally fine, but maybe you're just having a UI issue. And that can make people think, oh my goodness, where did my money go? Like, do I have no money in my account at all? So the next thing that's interesting to think about here is, can I deposit funds and send payments? That's where my mind goes if the balance reader service is not working. Let's learn a bit more about our system. So we can deposit money. So here I deposited $1,000 while the balance reader service was in a black hole and everything worked out okay. You can see the transaction record is just here, adding $1,000. So, and it also tells us that the deposit was successful, but the current balance didn't update. So it didn't tell us that now we have over $8,000. It just looks like we still have no money in our account. But if I try and send payments, I'm actually unable to click send payments. So the user's unable to do this at all, and they'll get an error that the payment failed due to the balance reader. So that's what this looks like. Payment failed, IO error on get request, balance reader. So we're actually seeing that we have a connection refused error because balance reader is currently unavailable. So that already teaches us a lot about our system, how it does and doesn't work. Okay. Interesting. I'm hearing that it's a bit blurry. All righty. So everything has its wonders, even darkness and silence. So this is a free demo environment that you can use to learn about black holes. I think that's a really good thing to check out. What I'm going to do as well is share in the share my slides in the chat as well, so you can pick that up and have a look at it. Alrighty. So now you can actually grab that link, you can clone the repo, you can start Minikube, and you'll be able to do that. Let's see. I see maybe there's an issue with my internet, so I'll have a look and see what I can do there. I've got a backup internet, so we'll see. But you do have my slides in the chat. Alrighty. So what you want to do is clone the repo, click Minikube start, in Cloud Shell terminal, run kubectl apply. You just need to run this YAML file, then click Cloud Code, run on Kubernetes. And then to create your black holes, create a namespace for Gremlin and install Gremlin as a Helm chart. So that's this repo over here. And this repo, you can actually use Gremlin totally for free if you click this link here. Alrighty. So now the next example that I want to look at is, let's see how a black hole impacts our transaction history service. So this is a different service over to the right, and this is showing us our history of transactions, which we looked at before. We could see that we deposited $1,000 into our account. So let's see what happens. You know, it's a good thing to actually guess and see, to think to yourself, what do I think would happen if I was to make this service unavailable? Can I still make deposits? Can I make withdrawals? Can I send money? Am I able to see my transaction history? Let's have a look. So you can see, let's have a look now. Alrighty. So this is what our transaction history looks like before we'll do a black hole attack on it. So we have our credits and our debits, and you can see here all of the information displays nicely. So something we can do though to mitigate against a black hole, depending on the service, is that we could actually scale replicas, because this is something good to think about. We could run kubectl scale deployment transaction history, replicas is equal to 2. So I think that this is a good thing to know about. Often when I think folks are using auto scaling functionality or Kubernetes scaling functionality, they don't think to look and see how many pods do I actually have running? Because if you only have one running, then you're not really using the benefits of Kubernetes, the fact that you can easily create additional replicas and have them running. And then if one transaction history pod is not available, you can fail over to the second one. So you can see here what we've done is we've created 2 transaction history pods, because if one is not available, then we're not going to be able to see our transaction history, that it just won't show up. So instead we've run that command to scale the replicas to 2. And now you can see that we actually have 2 if we run kubectl get pods. So this is a really good and interesting thing to think about right here. How many pods do you have for each of your services? And also, can you actually create additional pods for those services? For something like transaction history, it's not good if that pod just is unavailable or something goes wrong with it and then there is no transaction history. Customers will get very worried about that because they'll think that something is wrong, and then you'll start to get a lot of phone calls, a lot of tickets, a lot of people coming into the branch, a lot of people complaining on Twitter because they're just really worried about it. Alrighty. So what we want to do here is let's send 50% of transaction history pods into a black hole. So we're only going to take half of those pods. And you can see here, this is what our new architecture diagram looks like for transaction history. And what we think will happen is there will be a very short outage and then the other pod will take over. So we'll say, let's just take away 50% of the pods, and actually it should flip over and everything should be fine. So yes, we're still able to see transaction history and we don't get any error messages at all for that, which is really amazing. So that's a pretty cool thing to know about Kubernetes if you haven't used it before. And I think a lot about this actually like databases. So I led the databases team at Dropbox. And if you think about MySQL replication, right? You have your primary and then you have replicas. So that's how Kubernetes really works, is you're going to have replicas of services. And I think that that's an awesome thing to bring to just running web applications, running different types of important services like internet banking. The fact that you can actually say, I've got extra services running and it's really easy to scale up, to scale down, to make sure that I always have them available. And it's all automated, which is awesome as well. So now let's look at a different example. What happens when your shopping is involved? So we'll do an e-commerce example. This is a distributed system and e-commerce example of this. So you can see here, we've got a number of different services. And what we're going to do is we're going to black hole the ad service. So this is the ad service up here. It just displays ads. So the ad service actually creates these ads down the bottom here. And you can see here, I've just put little marks on it. So if we make that ad service unavailable, we think it should just disappear. The page should look clean and nice. We don't want to see any errors. So let's go and grab that service, ad service. Let's black hole it and see what happens. Do we get a nice graceful degradation of the customer experience? Yeah, it just disappears. The page slightly gets a little bit smaller and everything looks nice. So that's an awesome way to look after that. The other thing we could think about, which we just learned before, is we could create additional replicas. So if we black hole ad service, and have additional replicas that can come up, then that's going to be really good. But our experiment was successful in the fact that if that entire service is unavailable and we're not able to have additional replicas take over and be able to display that service, then we'll actually see that everything looks nice. It didn't negatively impact our customer experience or our overall SLOs. Sometimes things are hard coded, right? So taking down an ad service could actually crash the entire website and make people unable to make purchases. And that's when we have bad situations, but that's why black holes are really nice. So let's think about that a little more. What are the different sizes of black holes that we experience or create? So we can have micro black holes, stellar black holes, or supermassive black holes. So we can experience and create black holes of all sizes. And when creating black holes, it's good to start micro and then gradually expand the blast radius of our black holes. So for example, if you think about it like this, if we start off with micro, that could be, let's just black hole one pod, or even smaller, let's black hole one container in one pod, because you can run multiple containers in a pod. And then as we gradually expand the blast radius, we might say, let's black hole an entire service. So we're going to black hole everything, the whole deployment set, all of the pods that exist in it. Then if we look at even bigger, we could say, let's black hole multiple services and see what happens if they're not available. Now let's go even bigger. Let's black hole an entire region. And this is when you think about region failover and what that actually is. It's actually a really safe way to do a region failover exercise. So, I think in the past, a lot of folks might have done a region failover, like say, well, let's do it like real life. Let's shut down that entire region and make sure that we can fail over everything. But that's really destructive, right? Because you have to shut everything down and then you have to bring it all back later. And a lot of errors can happen when you're doing that. So if you think about it as a black hole, you can actually make a region unavailable for like 60 seconds, and then you can turn it back on like that. So you're just saying, hide it and now bring it back, which is really cool. That's a great way to do a region failover exercise. So how do black holes impact observability? Another great thing to think about here is if you create a black hole, then what can actually happen is you can test your observability. You can test what happens if that service is unavailable. Can we see that in our monitoring? Do request times go up higher? Does it take us longer to be able to reach certain services? Can we actually notice that? Do we know what services are impacted via our monitoring? Can we see that in our logs as well? These are all really good things to think about. And what can we learn from black hole related failures? We just saw today that you could actually learn quite a lot of different things. Like for balance reader, if that's not available, we have a bug that we're no longer able to send payments. And also we don't get an error. We just see that we have no balance and 3 dashes. So how can we use black holes to learn and make our systems more reliable? This is a really great way to proactively test what's happening with our systems, especially for distributed systems, how different services impact each other. Something that I recommend doing is running game days for sure. And then when you're figuring out your reliability plan, black holes are a big part of it. I really like them, especially because you can use them for region failover, service failover, that type of thing. Being able to test what happens if a dependency is unavailable. Do I fail over to another one? So for example, say that you use Google Maps to be able to display a map on your contact page. If it's not available, if there's an outage with Google Maps, can you fail over to a different map provider? And is that all built in and everything works well? You can test that by creating a black hole. And in this pyramid, what I like to think about is a lot of what we have to do is actually tactics. So this is at the bottom. And then above that is our strategic goals for our reliability plan. Above that is our mission. What are we really trying to focus on? What's our vision for our company? And then what do we value as a team and as an organization? And so just again, that is the link for the Google Cloud banking platform example. So you can check that out. That's a really good repo that I recommend. And it's just called Bank of Anthos. And also another thing is that if you would like to grab a copy, I wrote a book with a few friends for O'Reilly. It's an ebook called Reducing MTTD for High Severity Incidents. And you can actually get a copy of that. Just going to grab that link and post it in the chat. There you go. And thank you so much. So now I'm available to take questions. And if you've got any follow-up questions, you can also find me on Twitter. Thank you.
Thank you, Tammy, for the great presentation. Can you hear me clearly and everything is cool?
Yes, I can.
That's great.
Yep. Hi there.
That's great. Thank you so much. I think I never heard in a computer science related presentation black hole so many times said, but it was really great. So thanks for that.
Thank you.
First of all, I wanted to ask you that why did you pick the topic? So what is the reason behind?
Yeah, so I think like one of the most useful failure modes to learn about is networking failure modes, because there actually is a lot of different type of networking related issues that will occur in computer science. And I think often, you know, maybe folks don't study networking when you're at university, or maybe you have a dedicated networking team. So maybe they have all of the networking tools and they're the ones that get escalated to. So I think that that's actually one of the really important things to check out and think about. But I think, yeah, that's generally why I like it. The other reason too is if you think about black hole in terms of being able to do a region failover, like that's a game changer. That's just, you know, a 60-second region failover test. You know, that's awesome, because often folks will spend months planning to do region failover and it's a whole day exercise. But why can't it just be something we do all the time and it takes 60 seconds? Like that's way better.
Yeah, sounds much better. And how many people around the world are doing chaos engineering? Do you have some glimpse about that topic?
Yeah, so there's probably around, I'd say, I mean, now there's like thousands of people doing chaos engineering, so tens of thousands for sure, and that's really exciting. So actually, if you join gremlin.com/Slack, which I'll post in the chat, that's actually very cool. There's over 8,000 folks in there from companies like Google, Amazon, Dropbox, all these different places, Gremlin, of course, and we're all in there to take questions. There's a learning channel and also a mentoring channel. And also the other thing too is I'd say most of the biggest banks in America now are all practicing chaos engineering on a daily basis, which is super exciting to see because they really want to make sure that our services and banking applications are reliable for all of the customers. And then also it's very popular in e-commerce. So a lot of online applications which sell like goods to folks, groceries, all these sorts of things. So Target, H-E-B, they're practicing chaos engineering right now, and they've been doing it for many years. So that's also awesome as well.
That is actually a really great Notice. Okay, I'm just searching for the questions in the Q&A, and we have one question from Kylie, and that was, what tools and test frameworks to automate chaos engineering would you recommend?
Yeah, so I definitely recommend Gremlin. That's where I work, and we create a chaos engineering platform. So if you want to get started, you can just go to gremlin.com/buttons. I'll post that in the chat. That's my nickname. But I definitely recommend that for automation. The other thing too is like, think about how you're going to automate it. So what I like to recommend is a few different ways to automate. One is automate it by adding it to your CI/CD pipeline. So this is something that quite a lot of customers are starting to do from Gremlin. And I actually did write some articles on it as well. So I'll try and post that in the chat too. But for example, I've seen a lot of people using Jenkins and also a lot of people using Drone to be able to automate their chaos engineering exercises. And that's really cool because if you think about that, say when you deploy to staging, then what you're doing is you're automatically running a series of chaos engineering experiments. And then as you deploy to production, you're also running an automated set. A lot of the time what folks do is they start by just running their chaos engineering experiments in staging or pre-prod, and that's where they're automatically running every time they do a new deploy. So they trigger the chaos engineering pipeline to run with Jenkins, and that's super awesome. And then the other way to think about it too is by using an API, right? A chaos engineering API to be able to automate all of your work. So say, for example, you want to do a region failover exercise once a quarter, you could just automate that, write everything up, make sure it's all written in code. SDK, there's quite a few. There's like a Python SDK you can find on GitHub for Gremlin. And then you don't have to say, like, what if someone leaves the company? Now no one knows how to practice region failovers, and we haven't actually tested this before and made sure to capture the results. So I also really like the idea of thinking like a scientist, making sure that you codify everything, write down the results, capture how everything worked out. And then when you come back and do your next region failover exercise, you can look back at the past and learn and improve things and make them better. And then you can look at saying, instead of running it once a quarter, you could say, hey, like, let's run it once a month. And then, you know, something that we did at Dropbox is we would run DNS failover actually once a week. So that was a really cool, different type of chaos engineering experiment we're doing related to networking. So you just grow your confidence if you codify things and look at the results, I think.
Thank you very much for the answer. I have one more question regarding if you are like a rookie, where shall I start? So which is the basis of the chaos engineering, and what kind of tips or hints you can give if someone wants to implement it?
Yeah, definitely. So I recommend, like, you know, get in there and just give it a go. Try it out by using a demo application. So that's why I wanted to share the Bank of Anthos application today. And, you know, it's free to spin that up. It just requires, like, you know, one click to run it with Cloud Shell. And then if you check out my slides, which I shared in the chat, you can actually see that it's only like 5 steps to then have that up and running. And then you'll be able to actually start practicing chaos engineering. And there's a lot of different attack types. So today I just focused on one, which is the black hole attack, but there's also other attacks like DNS, spiking CPU, spiking IO, memory, disk, a lot of different things that you can do, killing processes, shutting down pods or shutting down nodes. And so you'll just learn a lot from practicing it. And what I recommend doing, if you've had a bit of a play yourself as an individual, is say to your team, hey, what if we just run a game day? So let's do that. We'll get together and run a game day as a team. And maybe you say have 3 or 4 people where you get together on a Zoom call and you pick part of your application on staging or pre-prod to inject failure into to learn from. And that to me is the best way to do it. I love to learn by doing. So that's definitely my preferred way to recommend to everyone.